Good morning to you all. Today we continue with the parasitology, diagnostic parasitology. Diagnostic parasitology, today we go with the Entamoeba hartmanni. Quickly. Here, Sarcomastidoptera, Sarcodina amoebas. This is where we are now. E. hartmanni. That's according to the taxonomy. According to the site of infection, we are here in the intestinal or luminal amoebae. Again, this is non-pathogenic. All the gastrointestinal amoebas, apart from the histolytica, they are all non-pathogenic. They don't harm the human being. Only in certain circumstances where you have low immunity, immunocompromised, maybe there it can cause a problem. But normally, they are non-pathogenic. That's the life cycle of all the non-pathogenic amoebas. And they look all the same. They have the same or the identical life cycle. If you see here, Entamoeba coli, Entamoeba hartmanni, Entamoeba pollici, Undulemax nana, Iodamoeba bochlei. All of these, they have the same life cycle, similar, identical. Where in the stool, you can see both the trough and the cyst. That's the stage you see under the microscope is diagnostic stage. So in this case, trough is a diagnostic stage and cyst is a diagnostic stage. In the infection, trough doesn't play any role at all, because if it's eaten or ingested by the human, it will be digested by the stomach acids, the HCl. But on the other hand, the cyst, if it's ingested, then the infection develops. Why? Because the cyst can resist the HCl and the acid in the stomach, and then can pass through here, passes through here, the stomach, and goes to the intestine, where excistation occurs. Cyst becomes trough. So the infective stage is cyst for all the entamoebas, or the amoebas. So mature cyst ingested. Non-invasive colonization. Again, apart from E. histolytica, the rest, they cannot penetrate the wall of the intestine and go to other systems like liver. No, it's only the E. histolytica, and in rare cases, not very common. So this is the idea, is that there's non-invasive colonization. It is restricted and confined to the intestine, the small intestine and the large intestine. And that's how it looks. This is the trough. It has trough stage and cyst stage. This is the trough where there is one nucleus, and in the nucleus centric, in the middle, there is the karyosome and the chromatin around, which is evenly distributed. They are almost equally distributed on the periphery. And there is the fine granular cytoplasm around, and there is this pseudopode, the false leg, pseudopode. Size is between 5 to 15 micrometers, smaller than the E. histolytica. Finger-like projection, but does not exhibit progressive movement or motility like the E. histolytica. Histolytica has finger projection, but it can move relatively fast. Although all the amoebas, they move slowly, but relatively, histolytica is fast. This one is not. Single nucleus, as all amoebas, the trough has only one nucleus, mononucleated. Cytoplasm may contain bacteria, but never RBCs. The one that contains RBCs is E. histolytica. That's the cyst. 1 to 4. 1 to 4. 4, maybe very rare to see it 4, like E. histolytica. Most of the time, 1, 2, 1, 2, maybe 3, but 4, rarely. But in general, it's between 1 to 4. Fine granular cytoplasm, centric small karyosome in the middle, and the chromatin is evenly distributed around the periphery. Refractile cell wall, which means they are going to produce halo area because of the light reflection coming from the microscope. Diffuse glycogen mass here, size is 5 to 10. That's how it looks. You see, this is the drawing, the figure, and this is the reality. And all the time, the figure is something and reality is another. So here we can only see one nucleus, chromatin. There's one karyosome in the middle, dot. You can see the dark area here, looks like chromatoid bar. And this is iodine stain. If you remember in the E. histolytica, we said that the chromatoid bar, they disappear when the cyst matures. Here, no. The cyst matures and the chromatoid bars remain. And it has a glycogen mass also, unlike the histolytica. It's a smaller copy of the E. histolytica. That's why sometimes we call it dwarf. Dwarf means very little. Diagnosis, you can refer down below this video to the E. histolytica. There we explained all the diagnosis for the amoebas in general in details. Quickly, we do here wet mount, saline and iodine. So the saline, you can see the cyst and the trough. In the iodine, you can see only the cyst, but clearer, so that you don't make misdiagnosis. You don't diagnose the white blood cells as they are cysts. Then stain smear trichrome or iron hematoxylin, but trichrome is better. And then concentration, so the sedimentation and flotation, which we will talk about in the lab. Because this is small, sometimes they used what we call ocular micrometer. So there is the ocular piece, the eyepiece, but it has a graduation like this. So you can put it here and then see the size. And depending on the size, you can tell if this is E. histolytica or hartmanni. But this, again, this is the technology of the past. You cannot depend all the time on this, because sometimes E. histolytica, when it's immature and small, it has the size of the E. hartmanni. Therefore, much better nowadays is to do what? PCR. PCR, you can be almost sure, close to 100%, that you are dealing with E. hartmanni. Again, Entamoeba histolytica, Dispar, and Moshkovsky, the three sisters, plus the hartmannis, may become morphologically indistinguishable. You cannot tell. If you depend on the size and the shape, the accuracy will be very low. Sometimes young E. histolytica is just the size of E. hartmanni. Here it says trichrome. If you are a person in the lab who depends on morphology, trichrome can give you very nice idea and more sensitive than the non-stained, but the close to 100% is again the PCR. We can show you this one, Abu Zahra. That's just a research paper. This research paper, which was published in Acta Parasitologica from Rania Abu Zahra, Egyptian. And just let's read the conclusion very quickly. This conclusion here. Let me read for you. Conclusion. This study demonstrates a high prevalence of infections caused by non-pathogenic Entamoeba species, like Dispar, Moshkovsky, hartmanni, along with the pathogenic histolytica. Hence, we recommend PCR assay as an accurate, rapid, effective diagnostic method for the detection and the differentiation to distinguish of the four morphologically indistinguishable Entamoeba species in both routine diagnosis in the normal labs and epidemiological surveys. Understood? Let's go back. Okay, this is the PCR. So this is the morphology of E. hartmanni. If you see here, it looks like T, which means this is iodine. Almost, it's not really circular, little bit oval, but you can see the halo. Maybe this is the chromatoid bar. A nucleus. Can you see nucleus with me? Maybe one, this one here, other side, on the left side. This one also, we have two here, chromatin, calyosome in the middle. Maybe this is chromatoid bar, binucleated, two nuclei. Unfortunately, this is the focus here is not very clear. If you look here, this is wet mount, and we can see this is the cyst. The three here are the cyst, and this one is the trough. And in the cyst, you can see one nucleus here, one nucleus here, one nucleus here. There is a vacuole here. If you see down here, there's a vacuole. Chromatoid bar maybe here. I can see it. This is circular. This is the oval, little bit in between. This is the trough. So in reality, you might not see the ideal picture. Okay, chromatin is even here. This is a trough, and you can see here one nucleus, calyosome in the middle, and evenly distributed chromatin. This is trichrome stain, the best stain for the for parasitology. The same here, calyosome in the middle, and there is the chromatin. The same here also. Three of them, they are trichrome stain. This is greenish here. This is almost purplish. Single nucleus all the time. This is the trough. Treatment and prevention, treatment and epidemiology. As we said, these amoebas, including this one, they are non-pathogenic. And sometimes they gain access and they get inside us. None of us would like to have parasite in his or her intestine. So therefore, we get rid of it by having a course of flagyl, metronidazole. What does it mean if you have this trough, the non-pathogenic trough or cyst, the infection inside you? It means there's poor hygiene. Sanitation is not okay, and the hygiene is not okay, whether this is personal hygiene or the area around you. So my recommendation is that you have to get rid of it. Some people say, don't give treatment. I say, no, give treatment, because it's not normal to have parasites inside you. Treatment, chain of infection, prevention, and epidemiology. So if you look here, just a comparison in the shapes and the sizes. This is Entamoeba histolytica 12 to 25 compared to this 5 to 15. So this is smaller, dwarf. 10 to 20, 5 to 10. Chromatoid bars here, they are lost when they mature, but here they are retained. 4 nuclei, 4 nuclei, almost the same. So see how it looks? 4, but we can only see 2 here, and chromatoid bar. 1 here, and a chromatoid bar. 1 here, 1 here, and a chromatoid bar. So 4 is not something you see every time. Okay. This table here, which is a comparison table, you can see all the characteristics and all the GI tract amoebas. So histolytica 1 to 4, hartmanni 1 to 4. Fine granulations in the cytoplasm, like a ground glass, a glass that has been ground into small pieces like flour. Fine, centric, the caryosome. Chromatin, evenly distributed in both. Chromatoid bar in young cyst here. Here it's in cyst, not young cyst, but cyst. This has to go away. RBC, the only one that has RBC is the histolytica. The rest, no. Maybe little apart from the gingivalis in the mouth. Bacteria trough, yes, rare, and here it's ingested. Rapid directional motility, the only one that has this characteristic is E. histolytica. The rest, they are not rapid. Vacuole in the cytoplasm, histolytica no, in most cases. Here, yes. This is all for hartmanni. Now let's go to the most common Entamoeba species, which is the E. coli. Most common. Most commonly encountered in the lab. Sarcomastigophora, Sarcodina amoebas, we are here. Taxonomically, we are here. According to site of infection, we are in the intestine, amoebas, so we are still here. Nine amoebas in the GI, three amoebas in the brain. The red one with the star is the pathogenic, and the rest they are not pathogenic. While in the brain they are all pathogenic because it's the brain at the end. Entamoeba coli, most encountered in the labs. You can refer to the other amoebas for the life cycle because they are all identical. Diagnostic stage, cyst and trough. Infective stage is the cyst only. We have explained this in the previous video or lecture. This is the trough. As you see here, the chyosome is it in the middle? No, it's on the side. It's not centric, it's eccentric on one side of the nucleus. And the chromatin, if you look here, there is high amount of chromatin on this side, and there is low amount of chromatin on this side. So the chromatin is not evenly distributed. Maybe this is the only one. Chyosome, eccentric, not centric, and chromatin unevenly distributed, not evenly distributed, as in the previous two, hartmanni and histolytica. It has bacteria inside, it eats bacteria. Coarse granular cytoplasm, not fine as in the histolytica. Why? Because this eats lots of bacteria and collects debris while it's moving. So these are the bacteria and vacuoles. Blunt pseudopod. So the pseudopod is not finger-like, it's blunt. Okay, so it moves in all directions, but not in a projection, like histolytica. Size 15 to 50. Do you remember the size for the E. hartmanni? 10 to 15 and 10 to 20 for the histolytica. This one 15 to 50, which means this is the biggest. The biggest one is this one. This is how it looks. Chyosome, eccentric, chromatin here more than here, so not evenly distributed. Maybe this is something like bacteria or something else, or debris. And this is vacuole, food vacuole. Blunt pseudopod, sluggish, non-progressive motility. The motility is not very fast compared to the histolytica. Mononucleated, single nucleus, as in the case of all trophozoites of amoebas. This is the cyst, and you see here many cysts. 4 to 8, usually 4 to 8. Most of the time you find 5, 6. That's what you see. But there are exceptions. So coarse granular, eccentric small chyosome, uneven peripheral chromatin, cell wall, and chromatoid bars. But then when they mature, they disappear. Look at this here. 1, 2, 3, 4, 5, 6. 6. And it has a halo around. If you look here, there's a halo, reflection of light because of the hard shell of the cyst. Size 10 to 35. Trough 10 to 50. This one 10 to 35. Largest cyst of all. And largest trough of all amoebas. As I told you, 4 to 8. That's the usual. 5, 6, 7, 4 to 8. There are reports that it reaches up to 16 and 32. Maybe it's a rare report. Most of the time, above 4. 4, 5, 6, 4, 5, 6, like this. And this number differentiates between the histolytica and this one. Histolytica, 1 to 4, most of the time, 1 to 2, 1 to 2. This one, 4 to 8, most of the time, 5 to 6. So from the large number of the nuclei, you can tell this is E. coli, not histolytica, plus the size. Because if you are inexperienced, in the future you become experienced, so you can tell that the size is very big. Young cyst, chromatoid bars, and glycogen mass. When it matures, they are lost. Diagnosis, again, go down to the histolytica lecture, and everything is explained in details. Quickly, we have wet mount, saline and saline and iodine, trichrome, stain, and sedimentation and flotation. Number of nuclei is the most important. Here, how much we have here? 1, 2, 3, 4, 5. And it's oval and it's big. Here, 1, 2, 3, 4, 5, 6. This is trichrome stain, this is iodine. PCR again plays a very significant role nowadays. Look, trophozoite slightly larger than E. histolytica, but may be difficult to differentiate in wet mount. Final identification is based on permanent stain smears, trichrome, and better based on PCR. Immature cyst of E. coli, which is small, E. histolytica, dispar, Boshkovsky, hartmanni, they will be similar like E. coli, but when the E. coli is small. Look here, we have a trough with 1 nucleus. We have a cyst with 5. 1, 2, 3, 4, 5. If you make focusing here, you can get the nuclei that are lost. As I told you, this is 2-dimensional, 2D, but in reality, they are 3D. Big ball with small balls inside them. This is a very rare one, which we got from the CDC. There is a large vacuole, immature cyst with 2 nuclei pushed to the margins of the cyst with large glycogen vacuole. This really happens. Now, let's have a look at images. Look here. This is not circular, it's oval, and it has 5. In this focus, it has 5. Maybe you can see more. 5, which means this is not E. histolytic or hartmanni. This is E. coli. This here has 1, 2, 3, 4, 5, 6, 7. Iodine, the same thing. This has 1, 2, 3, 4, 5. This one has 1, 2, 3, 4, 5, 6. And there's a vacuole here. All of the time, it's between 5, 6, 5, 6. This tells you definitely this is E. coli cyst. So the number of nuclei is very important. This is a trough, large, blunt pseudopod here, karyosome eccentric, and chromatin is very much on one side and very little on the other side, which means they are unevenly distributed, not equally distributed. The same here with iodine. Here, look, the karyosome looks centric, yeah? So this is an exception. And even the chromatin almost looks even. As I told you, these morphological features, sometimes there are exceptions. Not like PCR. PCR, it gives you definite. This is wet mount. Have a look. 1, 2, 3, 4, 5. Maybe this is 6 also. Chromatin uneven. Much chromatin here, too much chromatin here, and little here. Karyosome, this is centric. Sometimes it's eccentric also. This is supernucleate. Many nuclei. Look, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, 13, like this. 12 supernucleate. You will be lucky to see one of this during your life career. where there is a cyst with 12 nuclei. This is not mature, very mature. Thick cell wall, as you see here. Chromatin is uneven if you go. And look, this is karyosome eccentric. This is centric, eccentric. So you might see this or that. This one is a trough, and because it's wet mount, you cannot see the nucleus, because the nucleus is like DNA, and DNA is colorless. You only depend in the wet mount on motility. So if you see it moving, then this is trough. But nucleus, don't expect to see it in wet mount. You will see it if it's stained. That's very important. So if you look here, I cannot see the nucleus. Lots of granules, hyaline ectoplasm, this one here, ectoplasm around. There's a pseudopod is going to form so that it can move. These are cysts with many nuclei. So all of these cysts, if you look, they are between 4 and 8. This is 5. This is 5. Maybe this is 6. There's another 5 here. There's another 5 here, 6. 5 here, 5 here. 1, yes, 1, and maybe this is young chromatoidal bars. We have 1 here, around 5 or 6. The same here. Maybe this is not only 3 here. And there's chromatoidal bar here, or 2. Here 4, 1, 2, 3, maybe this 4, yes, okay. So you have to count. And not only that, you have to, if it's wet mount, you have to play with the focus, because 3 maybe or 4 on the same level and 1 down. So you focus so that you can see the down. But when you see the one that is down, you will lose the 4 up. You have to keep focusing so that you can see as much nuclei as possible to give diagnosis. That's the trough. Very eccentric. Do you think here the chromatin is even or uneven? Maybe this area. Maybe it's difficult to give the decision here. Look here, very eccentric, very eccentric. This one here, chromatin is uneven. You can see it clearly. This one, chromatin is uneven, very clear. And the karyosome is eccentric. This one, karyosome is eccentric. Chromatin is uneven. All of this is iron hematoxylin stain. And this is trichrome. The same thing as we said for the hartmanni. Prevention, treatment, and epidemiology. If you have this, get rid of it by a course of flagyl and make sure that you fix the hygiene around you. If you look here, which is the biggest? E. coli. You see the trough? 15 to 50, compared 5 to 10 and 12 to 25. And here also, we have the largest cyst, with many nuclei, the largest with the largest number of nuclei. The size and the number of nuclei. These are the two things or the two features we have to take care of. E. coli, 4 to 8, compared 1 to 4, 1 to 4. Granulation, coarse. Lots of debris and food are just engulfed. Fine, fine, eccentric and large. If you see here, most of them are centric, except this one. Maybe this one because it's the cyst only. But in general, the one that is eccentric is the E. coli. Uneven and thick, that's the chromatin here almost all the time, either absent or even. Chromatoid bar in young cyst, yes. RBCs, no. Bacteria is ingested in large amounts. Rapid directional movement, no, because it has a blunt pseudopod. And vacuoles in the cytoplasm, food vacuoles, they are abundant. That's it for today, ladies.